Hello everyone, this is Maushmi. Today I am here with some problems on electric charges and fields. So the first problem, 2-point charges minus q and plus q by root 3 are placed in the xy plane at the origin origin 0, 0 and at a point 2, 0 respectively as shown in the figure. The results in an equipotential circle of radius capital R and potential V equals 0 in the xy plane with its center at B, 0. All lengths are measured in meters. The value of R is dash meters, the value of B is dash meters. So, quickly look at the figure and let us analyze the figure in a substantial way. So, we have 2-point charges here. One charge is negative, it's equal to minus q, and the other charge is plus q by root 3. The first charge is placed at the origin, that is for this point. We have the coordinates as 0, 0, and the second charge is placed at a point whose coordinates are 2, 0. So this tells us that the distance of this point, you can understand the coordinates 2, 0, that the point will lie on the x-axis and its distance from the origin is 2 meters, and since the point lies on the x-axis, so its y-ordinate is 0. Now, this will result in an equipotential surface of radius r. So, these two system of charges, it results in an equipotential surface which is shown by this sphere, which is a circle of radius r. Let us assume the center of the circle and the radius is given as capital R. Now, the center has got coordinates B, 0. So, the coordinates of this point, let us take this center as C, and the coordinates of C are B, 0, which tells us that, let us take this point as O, which means that OC is equal to B. All the measures are in meters. We need to remember that. We have O, and let us take this point as, say we are taking this as D. So we have OD as equal to 2. This is so. Now, we suppose that the equipotential circle is cutting the x-axis at a point A, such that, let's suppose that this distance AD, we shall assume all the distances here. Let us assume this AC as equal to, this is nothing but the radius again, you can see this C is the center, so we have here CB, let us take this point as B, we have CB as equal to the radius, which is nothing but R, and this is in fact equal to, let us take these two distances, CD, let us assume it to be X, and AD, let us assume AD to be equal to X dash. So, as we can see, AD plus DC, this is equal to nothing but R. AD is, we have supposed this as X dash, and CD we have supposed this as X. So, we have AD as X dash plus X is equal to R. We will be using this relation. So, these are the assumptions that have been made in the drawing. It has become a bit clumsy, but hope you follow this. Now, what we are told in the question is that the circle is equipotential. Now, what does this mean? When we say the surface is equipotential, it means that at every point on the circle, the potential is equal, and it's equal here. In this case, it's equal to 0. So let us find out the potential at any 2 points on the equipotential surface, and as we know, it has been given in the question that the potential is nothing but equal to 0. So let's work on this. We have, say, we are trying to find out the potential at the point A. Now, potential at point A can be calculated as a sum of potential at the point A due to the charge minus q and also due to the charge q by root 3 at D. So, the sum of these two potentials should equate 0. So, at point A, the potential, net potential in fact is equal to 0, and this potential is actually a combination of two potentials. So, let's recall the formula for potential. We had potential equals 1 by 4 pi epsilon naught q by r. This was the original formula, where r was the distance of the charge q from the point at which we are finding out the potential. So here the point considered is A. So one term for the potential will come because of the charge minus q. Let's write that. We have 1 by 4 pi epsilon naught. The charge that we are considering is minus q by r. What is r? The distance between the points O and A. What is the distance between the points O and A? If you take note, we had OD as equal to 2, and OA will be nothing but equal to OD minus AD. So we have this as 2 minus x dash. So this is the potential that we had, 2 minus x dash. Now similarly, we have another potential here, the potential at point A due to the charge q by root 3. So similarly, let us write the relation. We have 1 by 4 pi epsilon naught. The charge in this case was equal to q by root 3, and the distance is the distance between A and D. So that distance between A and D has been supposed to be equal to x dash. So this is x dash. Now sum of these two potentials is equal to 0. As you can see, the first term is negative. When we take this term on the other side, the charge changes its sign, and accordingly we can cancel out the common terms. Q will also get cancelled out, and we are finally left with 1 by 2 minus x dash. This is equal to 1 by root 3 x dash. So this is what we have. Let's solve this to find out the value of x dash. We have 2 minus x dash as equal to root 3 x dash, or x dash may be written as 2 by root 3 plus 1. So this is the value of x dash. So x dash is equal to 2 by root 3 plus 1. Now let us consider the potential at the point B. Again, since the surface is equipotential, the potential at point B will also equate 0. And let us look at the potential, the net potential at point B. The net potential at point B will be that due to charge minus q and due to charge q by root 3. So let's write it down. We have 1 by 4 pi epsilon naught minus q by the distance between O to B. So the distance O to C is equal to B, and we have BC added to it, which is R. So we have B plus R here. Now B is nothing but again equal to, this was equal to 2, and we had x here. So we may write this as B plus R, or it will be better for us if we write it as 2 plus x plus r. And this is equal to, or sum of this with the potential at point B due to the charge q by root 3. Let's look at that. We have this at 1 by 4 pi epsilon naught. This is q by root 3 and the distance is dB. So just look at dB. It is nothing but r plus x. So we have this as r plus x or x plus r. Now this sum is also equal to 0. So taking the terms on the same side and arranging the terms, cancelling out the common terms like 1 by 4 pi epsilon naught will get cancelled out. Q will also get cancelled out. Ultimately, we will be left with 1 by 2 plus x plus r is equal to 1 by root 3 times x plus r. So let's solve this further. We get it as root 3x plus root 3r. This is equal to 2 plus x plus r. So you can see here we have this as root 3 minus 1 whole times x is equal to 2 plus r times 1 minus root 3. The whole thing will be divided by, now we have this. So this is what we have here. Now x, or we already have x dash. Let's find out r from here. We have, this is root 3 times root 3 minus 1 times x plus root 3 minus 1 times r is equal to 2, or we may write r as equal to, from here we may write r as equal to, if you take note, this whole thing minus 2 by 1 minus root 3. So let's do it in the reverse way. We get this as 2 minus root 3 minus 1 whole times x minus, this is root 3 minus 1 whole times into x by, this is root 3 minus 1. So this is r that we get. So we already have the value of x dash and we now have the value of r. Let's substitute these values in this particular relation to get the value of x. Let's work this out. So we have r equals, this is let's directly work with this. X dash was equal to 2 by root 3 plus 1 plus x, and r is equal to, let's separate the terms over here. We have r equals 2 by root 3 minus 1 minus of x. So we have this as 2x. So you can see that 2x is equal to 2 by root 3 minus 1 minus 2 by root 3 plus 1. So we can imagine 2 as getting separated out and it will get cancelled. Finally, we have x is equal to, let's take the LCM. We have this as root 3 squared minus 1 squared, and this is root 3 plus 1 minus root 3 plus 1 again. So finally we get x as equal to 2 by, this is 3 minus 1, that's 2. So we have x equals 1. So we get x dash as equal to 2 by root 3 plus 1 and x as equal to 1. So let's now put in the value of x in the expression for r and get the value of r. So we have r equals 2 minus, this is root 3 minus 1 times 1, which is minus root 3 plus 1, and in the denominator we have root 3 minus 1. So this is 3 minus root 3 by root 3 minus 1. So this is ultimately so you can do this here. We have r equals, we can multiply, rationalize the denominator. We have root 3 minus 1 multiplied with root 3 plus 1. You can write it as root 3 square minus this, and this term is this, root 3 plus 1. If we see the result, we have r equals 2 in the denominator, and here we have 3 root 3 plus 3 minus 3 minus root 3. So this gives us r as equal to 3 root 3 minus root 3, that is 2 root 3 by 2, or r is equal to root 3 in meters. And b, if you take a note at b was the coordinates of the center. So if we have to find out b, what will be the value of b here? So b here, as you can see, b is equal to nothing but OC, which is nothing but 2, that is OD plus DC. B is equal to OD plus DC. OD is equal to 2 and DC is x. And we already have x equals 1. So B will be equal to 3. So wonderful problem. Let's proceed to the next one. Again a problem involving few concepts. Now 6 charges are placed around a regular hexagon of side length A as shown in the figure. 5 of them have charge Q and the remaining one has X. The perpendicular from each charge to the nearest hexagon side passes through the center O of the hexagon and is bisected by the side. Which of the following statements are correct in SI units? So have a look at the diagram. We have a regular hexagon, which means that each side of the hexagon will have the same magnitude or the same value in fact. Now, here there are 6 charges which are located at the positions you can see. We have 5 charges which are all equal to the same magnitude Q, and the 6th charge has got a magnitude of X. Now what we need to find out is for different values of X, which of the following conditions will get satisfied. So here if you note that the distance between each charge and the center, this distance is in fact bisected into 2 parts. Bisected, which itself means each part has got equal length. So why do we require this? We shall see very soon. So this length is in fact equal to A, the entire length, and each part, since this line is bisecting the side of the regular hexagon, so this means that each of this length is equal to A by 2, because the total length is equal to A. So this line is bisecting this particular side, means that it is dividing the side into two equal parts, each part having a length of a by 2. Now, if we try to find out this particular length, then what will be the answer? Let me take this triangle as OAB. You can see the triangle OAB. If you take note, here AB is equal to a by 2, OB. Suppose we need to find out OA. As you can see, this is a right angle triangle. We can write by Pythagoras theorem that OA square is equal to AB square plus OB square. Now here if we try to find out AB square, it will be equal to OA square minus OB square. Now AB is known here. We need to find out the value of OB. So OB square from the diagram, OB square is nothing but OA square minus AB square. So concentrate on OB square. OA square, this length, this is nothing but equal to A, just as all the sides of the regular hexagon. So this is equal to A square, and AB, as we wrote down, AB is equal to A by 2. So this is A square by 4. So we get OB square as equal to 3A square by 4, or OB is equal to root 3A by 2. So this distance is equal to root 3A by 2. Now why am I worried with this? Let us look at the questions and try to find out why. Let's explore the cases now. When x equals q, the magnitude of the electric field at O is 0. Is this true? Let's look at the diagram. We have a regular hexagon and we have the center of the hexagon at the point O. We need to find out the electric field, in fact the magnitude of the electric field at the point O. We are not concerned with the direction, we are just talking about the magnitude. Now if x is equal to q, how will the figure change? If you take note, all the 5 charges are of equal magnitude, and if we have a 6th charge here at x also of magnitude q, it will mean that the entire thing has a symmetrical base. So the whole diagram, the whole figure will be symmetrical. It is a case of symmetry in fact. And as we know, in case of symmetry, the magnitude of the electric field at the point O will be 0. So x equals q basically corresponds to symmetry. And so the magnitude of electric field at O is 0. So we see that the first statement is correct. Now let's explore the second one. If we have x is equal to minus q, now minus q may be assumed as equal to q, sum of q and that of minus 2q. Now just look at this. We have sum of a charge q and a charge minus q. Now if this x is a combination of 2 charges q and minus 2q, then the charge q will give rise to the symmetrical structure which amounts to 0 electric field at O due to all the 6 charges. But we are still left with the charge 2q. Now considering only that charge 2q, if we try to find out the magnitude of the electric field, mind it, we are concerned with the magnitude. That is why we will ignore the negative sign of 2q here. Then how do we write the magnitude of electric field at O then? In this case, the magnitude of the electric field will be 1 by 4 pi epsilon naught. The formula was Q by R square. Q, the charge here is 2Q, and R square is nothing but the distance of the point from the point at which we are finding out the field. So we need the distance of the point X from the point where we are finding out the field. That is, we are concerned with this distance. Now, hope you understand why we found out OB. Just look at OB. OB is this particular distance, that is this much. And as we know that the site is bisecting the line which is drawn from that particular charge, which means that these two parts will have the same value. So if we have this part as root 3a by 2, it will mean that the remaining part is also root 3a by 2. But in the formula we have R square, which means that this is 2 times root 3a by 2 and whole square of that. So now let's analyze this. We have the 2's getting cancelled out. So the formula turns out to be 2q by 4 pi epsilon naught, and in the denominator we have 3a square. So if you take note at the values, you can see that we have this as So we have this as Q by 6 pi epsilon naught a square. Sorry about this, this has to be 6. So this option should be Q by 6 pi epsilon naught a square. So the electric field at O is Q by 6 pi epsilon naught a square. Now let us explore the third case. We have x equals 2q now, just the reverse of this. We have x equal to q. But of course, here till now we were calculating the electric field, but now we need to find out the potential. Now, hope you remember that potential is a scalar quantity, so the signs need to be taken into account. Now here, x is equal to 2q. So just have a look at the figure. We had 5 charges and then x is a combination of another 2 charges, that is q plus q. So ultimately the potential at O will be due to 7 charges of magnitude q each. So if we take note, we have this as potential at O will be V equals 6 for the total 6 charges. We can assume this to be divided into 6 plus q plus q, Then for the 6 charges q, for the first 6 charges, that is the system of the 6 charges, leaving this out, we have 6 times 1 by 4 pi epsilon naught, and this is q by r. So q by r is again this. And hopefully you understand that the distance is 2 into root 3a by 2. So if you take note, we have this as, let's add the additional term and see what it turns up to be. We have the last q left out. So for that we'll have 1 by 4 pi epsilon naught again, and we have q by 2 times root 3a by 2. So ultimately we have 7 coming up. So this is 7 into 1 by 4 pi epsilon naught q by, this is root 3a. So just have a look at the result. We have 7q by 4 root 3 pi epsilon naught a. So this statement is also correct. So this statement was incorrect. the third statement is again correct. And let us explore the last statement. We have x equals minus 3q now. Now in this case we were concerned only with the magnitude, but in case of potential, since it is a scalar quantity, so the signs also need to be taken into account. So if you take a note, we have x as equal to minus 3q. Let's look at it in the other page. So we have x is equal to minus 3q. Now imagine what this turns up to be. Now if x is equal to minus 3q, just have a look. We had 5 charges and here it's 3 minus 3q, that is 3 charges of negative sign, of just the reverse sign. So in this case, if we are considering, we can see that we may write this as minus 4q plus q. So just explore. We had 5 charges of magnitude q, and those with 5, out of those 5 charges, 4 will as if get cancelled out due to the effect of the potential due to these minus 4q charges, and we will be left with 1 in the system plus another q here. So just imagine, ultimately we may write the potential at point O due to the charge, due to a value of x equals minus 3q, we'll be left with 2 charges at the end, and each charge will bear a magnitude of q. So this is q, and r is equal to 2 times root 3 a by 2. Since the distance between O and the distance x, this much was equal to root 3a by 2, and this are bisected. So this part is also equal to root 3a by 2. So a sum of this will mean 2 times of root 3a by 2. So this is what we have. We write it as 2q by 4 pi epsilon naught and root 3a. So this is again, we have q by 2 pi epsilon naught root 3a. So we see that this particular option as mentioned in the question is also not correct. Let's check the question again. We had this 4 root 3, no, it's 2. So this option is again incorrect. So hope you enjoyed the problems. Stay tuned with Academy for more such problems. So this is incorrect. Thank you.